Need to lock down your FastMCP server with enterprise-grade authentication without rewriting your entire toolset? You'll see how to integrate WorkOS OAuth in just minutes, using their AuthKit domain to handle user authentication while keeping your existing tools fully protected. We'll configure the provider with required scopes, set up the callback flow, and demonstrate how clients automatically handle the OAuth handshake, all with minimal code changes. From FastMCP, import FastMCP. From FastMCP, server, auth, providers, WorkOS import WorkOS provider. Hash configure WorkOS OAuth. Auth equals WorkOS provider. Client ID equals client your client ID. Client secret equals your client secret. AuthKit domain equals https://your app AuthKit app. Base URL equals http://localhost 8000. Required scopes equals OpenID. Profile email. MCP equals FastMCP. WorkOS protected server. Auth equals auth. At MCP, tool. Def protected tool, message, SDR. This tool requires authentication. Return F authenticated user says. Message. If name equals main. MCP. Run transport equals HTTP. Port equals 8000. This demonstrates the OAuth proxy pattern for securing RPC services, where authentication is handled by an external identity provider while your application remains stateless. The pattern delegates user authentication to WorkOS via OAuth 2, then injects verified identity claims into each request, allowing your server to focus on business logic rather than auth infrastructure. What makes this distinctive is the complete separation between authentication flow and application code, with the proxy handling token validation and session management transparently. The flow follows the authorization code grant pattern, where incoming requests without valid tokens are redirected to WorkOS for authentication. After successful login, WorkOS issues a short-lived token that the proxy validates on subsequent requests, converting it into a standardized claims object for your tools. This design maintains clean separation of concerns. The auth provider manages identity, the proxy handles token mechanics, and your decorated tools simply receive verified user context as parameters. This approach solves the dual problems of authentication complexity and security maintenance. By outsourcing identity management to WorkOS, you eliminate password handling, session storage, and credential rotation from your codebase. The pattern shines in microservices, internal tools, or any scenario where you need enterprise-grade auth without building it yourself. The trade-off is vendor lock-in to WorkOS's auth stack, but you gain SOC 2 compliance, SSO integration, and reduced operational burden in return. Let's break it down. From FastMCP, import FastMCP. From FastMCP, server, auth, providers, WorkOS import WorkOS provider. Imports FastMCP, the core framework for building AI-callable Python tools, and WorkOS provider, the authentication handler for WorkOS OAuth integration. These are the foundational dependencies for creating a protected server with OAuth-based access control. Auth equals WorkOS provider. Client ID equals client your client ID. This initializes the WorkOS OAuth provider with your application's client ID. This credential identifies your app to WorkOS's authentication system, enabling the OAuth flow that secures access to protected tools. Without a valid client ID, authentication requests will fail immediately. MCP equals FastMCP. WorkOS protected server. Auth equals auth. This instantiates the FastMCP server with WorkOS authentication enforced. Every tool registered with this instance will now require valid WorkOS OAuth tokens, automatically handling token validation and scope checking. The server name, WorkOS Protected Server, appears in API metadata and logs for debugging. At MCP, tool. Def Protected Tool, message, SDR. This tool requires authentication. Return F authenticated user says, message. This decorator exposes protected tool as an AI callable function with enforced authentication. The WorkOS provider we configured earlier automatically gates access, ensuring only authenticated users can invoke this tool. The type hints and docstring define the tool's schema, which FastMCP uses to generate OpenAPI documentation and validate inputs. If name equals main. MCP, run transport equals HTTP, port equals 8000. This is the standard Python entry point guard. It ensures the server only starts when the script runs directly, not when imported as a module. The MCP run call launches the FastMCP server on port 8000 using HTTP transport, exposing all registered tools to clients. FastMCP WorkOS Authentication pattern. This implementation demonstrates how FastMCP abstracts OAuth complexity behind a simple decorator pattern, where at MCP tool automatically enforces WorkOS authentication without modifying your business logic. The client's first authentication flow requires browser interaction, but subsequent requests use cache tokens silently. Your entire server becomes OAuth protected with just 5 lines of configuration and a single decorator.
The server that demands authentication becomes invisible to the authenticated client.